Hello mathematicians and welcome back. Have you ever zoomed in on a photo on a phone or used a photocopier to blow a picture up to twice its size? When you do that, the picture gets bigger, but it does not get stretched or squashed. It stays in exactly the same proportions. In mathematics, we call that an enlargement. Today we'll learn how to enlarge a shape by a scale factor, how to draw the results accurately on squared paper, and then one rule that catches most people out. Let's get started. An enlargement is a copy of a shape that changes the length but keeps the same proportions. Let's look at two rectangles. The small one is a shape we start with. We call this the object. So this is the object. And the large one, the bigger one, is a shape we finish with. And we call it the image. So you need to remember these two terms. The object is the actual, the one that we start with, and then the enlarged one is called image. Look carefully. Here, the object is 3 squares wide and 2 squares tall, while the image is 6 squares wide and 4 squares tall. Every length on the image is exactly twice the matching length on the object, because every length has been multiplied by 2. So 3 multiplied by 2, that gives us 6, and 2 multiplied by 2, that gives us 4. So here we see that this number 2 is the scale factor. This is the scale factor. How do you define a scale factor? So a scale factor is simply a number with which each length or dimension gets multiplied to get the image. Also remember this very important point, because the object and the image have same proportions, we call them similar shapes. So it's just the enlarged one, but this has exactly the same proportions, like 2:3 and 4:6 also gives us 2:3. So both of these have same proportions. We call them similar shapes. They're same shapes, just the different sizes. Another important rule or the fact is, in enlargement, all the angles stay exactly the same. In enlargement, only the shape gets bigger, but the angles stay same. The picture gets bigger, the shape gets bigger, but it never gets distorted. Let's enlarge a shape ourselves. Here is a right-angled triangle drawn on a squared paper. We want to enlarge this by using a scale factor, let's say 2. We want to use scale factor 2. So, the method is wonderfully simple. We measure each side in squares and multiply that by the scale factor. Let's start with the base. The base of our triangle is 2 squares. This is 1 square and the other square, so that's 2 squares long. We multiply that by 2, so 2 times 2 is 4, so the base of our enlarged triangle will be 4. So here we have 1, 2, 3, and 4. So base of our enlarged triangle will be 4. Now the height. The height of our object in this case is 1, 2, and 3. It's 3 squares high. And the scale factor is 2. That means if we multiply 3 by 2, that will give us 6. So the height of our enlarged triangle will be 6 squares. Finally, we join the 2 points to get our third side, and there is our enlarged triangle, and that we call is an image. Notice that it is the same shape as original, just twice as big in every direction. And if you check with the protractor, every single angle would be the same as the original one. And this is the sign of the true enlargement. Now for the rule that catches most people out and a chance to be detectives, a student was asked to enlarge a shape by a scale factor of 3. He was given with this object and he was given the scale factor 3, but look at their answer. Something has gone wrong. They made the base 3 times longer. It was 1 and 2 squares first, and the new base was to be 2 into scale factor 3, that is base into 3, which is 6 squares. But look at the height. They left the height exactly the same as the original. Pause for a moment and see if you can spot the problem. The problem is it is a distorted one. For example, the angles here and here are now different. They just enlarged the base with the scale factor 3, but the height had also to be enlarged with the scale factor 3. So did you see it? The student only enlarged some of these sides, that is base in this case, not all of them. The result is a stretched and distorted final shape. It is not similar to the original shape at all. Here is the golden rule for you to remember. You must multiply every single length by the scale factor. In this case, you should multiply the base as well as the height by the scale factor. When the scale factor is 3, the base and height and every other length must all be multiplied by 3. And if that is true, then your enlargement will be perfect. Sometimes we are given a shape and its enlargement. So for example, we're given a shape and we're given its enlargement and asked to find the scale factor. This is just the working backwards. We pick a side on the object and the matching side on the image. For example, in the object, this base is 3 squares, and on the image, this is, let's say, 6 squares. Similarly, the other side is 2 squares, and here this is 4 squares. So what we do is we simply divide the length of the side of image with the length of the side of the object. So in this case, it will be 6 divided by 3, and that is 2. So we know that now. In this case, our scale factor was 2. But as a quick check, make sure that the same scale factor works for other side too. For example, in this case, the height was 4. And the height of the object was 2. So 4 divided by 2, this should also return 2. And if this works for all the sides and all the sides give the same result, that means the answer you found for the scale factor, that is 100% correct. So today we learned how to enlarge shapes. An enlargement makes a shape bigger while keeping the same properties or proportions, turning the object into a larger image. The scale factor is the number we multiply every length by. And the object and image are all the same shapes, same angles, but different sizes. To enlarge a shape, we multiply every length by the scale factor and then redraw it. And to find a scale factor, we divide an image length by the matching object length. Here is something to try for yourself. Take one squared paper, draw a simple rectangle that is 2 squares by 3 squares, and enlarge it by a scale factor, let's say 3. What are the new side lengths? And remember, enlarge every side, not just one. Take it one side at a time. That's all for today, mathematicians. Brilliant work. See you in the next video.